All right, greetings everyone. Welcome to the fourth part of the video for section 7.2. And we're going to finish up a little bit about one of the identities we were talking about in the previous video, and then look at a couple of new ones. All right, so I want to go back to this problem we've been working with, this 3 times sine of 2x minus 5 cosine of 2x. And we're going to think of this now as a function, so a sinusoidal function. And I want to know what are the max and minimum values that the function achieves. Now, when I look at it this way, it's kind of hard to answer that question because, we know that generally min and max values of a function relate to both the, excuse me, the midline as well as the amplitude. And here we could maybe say there's like a midline of 0 since we don't see anything here at the end, so it's maybe a plus 0. But as far as what the amplitude is, well, it looks like we have 2 of them, right? So that might be a hard question to answer. But we saw on the previous slides that this function could be rewritten as follows, as f of x equals, sorry, I'm looking for the answers in my notes. There they are. Square root of 34 times sine of 2x plus 5.2528. Okay. And we can use this now to find the max and min values. Because if we think about if we were to graph this function, well, we first of all see that there's nothing being added on the end here, so that'd be like a plus 0, which tells us the midline would be here at 0. And then the amplitude we see is root 34. So this sine function, and it would probably be shifted, but I'm not going to worry about that right now, as it oscillates above and below its midline, right? Well, it's going to go, the highest it'll go above that is root 34 units, and the lowest it'll go is negative root 34. So those would be our max and our min for this function. So we see the max value it reaches is root 34. The min value is negative root 34. Okay? All right. Some new identities. So these are the product to sum identities, which hopefully it makes sense why they're called that. Right here we see on the left, oops, all of these things here are products. And then the things we see over here are sums or differences. So that's why it's called the product to sum. And this is, again, a set of identities that you don't necessarily need to memorize, but as with the previous ones, you are expected to know how to use them. Okay, so let's look at some applications of these. So here we're asked to find the exact values of each of the following expressions. And notice in both cases, we see that we have a product of the sine or cosine of 2 angles that do not lie on the unit circle. Right, in the first case, we see 75 and 15 degrees, which are not on the unit circle. Second case, we see 7 pi over 12 and 11 pi over 12, which are also not on the unit circle. So we'll use those product to sum identities here since we see things being multiplied. And if we follow along with those formats from before, so we see this is sine of 75 times sine of 15, which we can think of sine as alpha times sine of beta. And the formula tells us that we can rewrite this as the following. So we'll have 1/2 times cosine of 75 minus 15, so alpha minus beta, minus the cosine of 75 plus 15, so alpha plus beta. And notice that cosine of 75 minus 15 and cosine of 75 plus 15 are inside the parentheses there. Okay, so let's go ahead and work this out. So this will be 1/2 times the cosine of 75 minus 15 is 60, and I should say these are in degrees, minus the cosine of 75 plus 15 will give us 90 degrees. And then we can go ahead and work these out. So we'd have 1/2 times cosine of 60 degrees. If we look at our unit circle, that'll be 1/2, excuse me, minus the cosine of 90 degrees. That'll be 0, again, looking at the unit circle. On the inside of the parentheses there, we have 1/2 minus 0, which just gives us 1/2. So we're looking at 1/2 times 1/2, which gives us 1/4. So sine of 75 times sine of 15, so sine of two angles that do not lie on the unit circle, give us this nice, concise answer of 1/4, which is kind of cool, right? Yeah, I know that's how you feel about it. Okay, let's look at the next one then. So here we have cosine of 7 pi over 12 times cosine of 11 pi over 12. And again, think of these as being in the places of the alpha and beta. So I'm going to write it up here for space. So following our identity for this, it tells us we can rewrite this as 1/2 times, in parentheses, the cosine of alpha plus beta, so 7 pi over 12 plus 11 pi over 12, plus the cosine of the difference, so 7 pi over 12 minus 11 pi over 12. And then we can go to work on the simplifying. So I have 1/2 times the cosine of 7 pi over 12 plus 11 pi over 12 would give us 18 pi over 12. Plus the cosine of 7 pi over 12 minus 11 pi over 12. Subtract the numerators there. 7 pi minus 11 pi gives us negative 4 pi over 12. And then things on the inside of the parentheses or inside of the cosine functions reduce. So we'd have 1/2 times the cosine of 18 pi over 12. I believe 6 goes into both of those, so that'll give us 3 pi over 2. Plus the cosine of 4 goes into both top and the bottom here, so give us negative pi over 3. And you hopefully recognize right away that 3 pi over 2 here is on the unit circle, so we can find cosine of 3 pi over 2, and that will again be 0. Plus, now, cosine of negative pi over 3. Now, negative pi over 3 is not explicitly on the unit circle, but let's think about where it would be. So since it's negative, we'd be working in the fourth quadrant. So we'd be down here with a reference angle of pi over 3. And if we think about it, there's another angle in the fourth quadrant on the unit circle that has a reference angle of pi over 3. And that would be 5 pi over 3. So negative pi over 3 is coterminal to 5 pi over 3. And the cosine there is positive 1/2. So we have that. Again, we work this out, it'd be 1/2 times 0 plus 1/2 is 1/2. So 1/2 times 1/2 gives us 1/4. Okay, so we get 1/4 for that one as well. And again, we have an exact answer for the product of the cosine of two angles that are not on the unit circle. Now, I do want to warn you, in both cases here, we got 1/4, but that will not always be the answer. So please don't have your takeaway from this be that every time you do one of these, you get 1/4. That is not true. All right, one more set of identities. So we just had product to sum. Now we have the opposite, the sum to product. And again, I know these are a lot of identities, but please don't be overwhelmed. You don't need to memorize them. You just need to know how to use them. And again, hopefully the name makes sense when you look at these, right? So it says sum to product. So notice that you've got things being added here that then become products, things being multiplied. All right, so let's use these then here. So we're asked to evaluate sine of 75 degrees plus sine of 165 degrees, and it should say we are being asked to find an exact answer here. Now, once again, neither of these angles, 75 nor 165, is on the unit circle. So we've got to use one of those identities. And again, we'll use the sum to product, and we're going to think of this as sine of alpha plus sine of beta. And our identities tell us we can rewrite this as 2 times the sine of alpha plus beta divided by 2. So 75 plus 165 divided by 2 times the cosine of alpha minus beta divided by 2. So 75 minus 165 divided by 2. Go ahead and simplify. Sorry, this should be a 75. So 2 times the sine of 75 plus 165, that'd be 240 over 2, times the cosine of 75 minus 165 is negative 90 over 2. And then we continue on from there. 2 times the sine of 240 divided by 2 is 120. Times the cosine of negative 90 divided by 2 is negative 45. And those are degrees. And what we again hopefully notice that sine of 120, that is on the unit circle, right? If we look at our unit circle, the sine of 120 degrees there in the second quadrant should be positive root 3 over 2. And then cosine of negative 45 degrees, this is kind of like the last one we were working with. So negative 45 degrees, not appearing explicitly on the unit circle. We know it's going to be down here in the fourth quadrant. And it would be an angle in the fourth quadrant whose reference angle is 45 degrees. And we know on our unit circle, an angle in the fourth quadrant with an reference angle of 45 degrees is 315 degrees. And the cosine of that is positive root 2 over 2. And then we can do some math-magic with our fractions. So make the 2 a 2 over 1. Got a 2 here and a 2 here that can cancel. Multiply across the top, do root 3 times root 2. It should multiply the numbers under the root, the 3 and the 2. That'll give us 6. On the bottom of the second one here, 1 times 2 gives us 2. So we get root 6 over 2. And again, we've come up with another exact answer here. All right, that's it for now. Thank you for watching.